Hey guys, today we're going to cover Form 4 Chapter 1 Functions. Let's go! So by the end of today's video, you'll be able to identify what's a function, function notation, what's not a function, domain, codomain range, and also sketching. Let's look at what's a function. So a function is the relationship between objects and images. This is the group of objects and this is the group of images. This relationship between the objects and images we call as function. 2 is mapped onto 4, 3 is mapped onto 6, 4 is mapped onto 8. So we can see that the relationship is by times 2. So the object times 2, we get image. Okay, let's look at how to write them. Writing the function is called function notation. So we can write it in two ways. F, and you can put this double dot x is 2x, or you can say f bracket x equals to 2x. These are two ways to write the function. You can choose either one. Next, let's look at if this is a function or not. So function, you can imagine it like a machine. If you put in one object, you must get one image. If you get more than one image, then it's wrong. So let's see. This one, we have one object, we get one image. One object mapped onto one image. One object mapped onto one image. So this is a function. Here, one object is mapped onto two images. So this is not a function. So one to many is not a function. Many to one. One object has one image. One object has one image. Even though both of them share the same image, but essentially one object only has one image. So this is a function. Many to one, as you can see, one object has more than one image. So this is not a function. So only one to one relationship and many to one relationship is a function. Next, if you have graph form, you can do the vertical line test. A vertical line test, you draw a vertical line. If the vertical line only cuts at one point, then it's a function. So as you can see, it only intersects at one point. It intersects the graph at one point, anywhere throughout the graph. This is a function. And for this graph, you see the vertical line test cuts at two different points. That means one object has two different images. So this is not a function. Next, let's look at domain, codomain, and range. So your domain is everything inside your object column. So domain would be 1, 2, 3, 4. You must write them inside these curly brackets. And then codomain would be everything inside the image column. So 4, 5, 6, 7, and 8. For range, we take the codomain, whichever images that has an object. So 4, 5, 6, 7 has an object, 8 doesn't have. So 8 will not be included. So just 4, 5, 6, and 7. Okay. Next, let's look at this graph. So for this graph, the domain would be the x-axis and the codomain and range would be the y-axis. X-axis would be the object, y-axis would be the image. So domain would be 3, 4, 5. And the codomain will be 6, 7, 8. Range in this case would be similar as our codomain because there are no images without an object. Okay. This is a bit special because this graph has continuous values. So for this graph, the domain would be a range. So from -2 until 7. And the codomain would be 1, y, until 19. So we have to write it as a range. The range would also be same. Okay, so we have to write in range form like this. Okay, the codomain takes 1 until 19. Range also 1 until 19. Okay, so what are the difference between these two graphs? This graph is called the discrete graph since it takes discrete values. The numbers are all discrete. Here, since the values are all continuous, that means it takes -2, -1.9, -1.8. It's a continuous graph. So we call this a continuous graph. Next, let's look at graph sketching. So let's say we have this question. They want us to sketch a graph of this for this domain. So to do this question, first let's draw our y and x axis. Okay, and here. This is y, this is x. So instead of y, we can also call this fx. Okay, so let's look at this equation. What we can do is we can sketch the graph without the modulus. It would be much easier that way. So y equals to 2x minus 3. If we compare it to y(x) plus c, our gradient is 2. Our y-intercept is negative 3. So the graph is going to cut at negative 3 here at the y-axis. And since the gradient is 2, it's going to be a positive upslope. Since this is a modulus graph, we have to flip whatever that is underneath, whatever negative value here, okay, whatever that's below the x-axis, we have to flip it up. So let's draw another line here, and then we can erase this already. So just now our y-intercept was negative 3. When we flip it, we will get positive 3. So now we need to draw the graph for this domain. So when x is negative 2, all the way when x is 4. So when x is negative 2, we put this into the equation, we get negative 7. So modulus of negative 7 will be positive 7. So this will be positive 7. And when x is 4, we put this into the equation, we get 8 minus 3, we get 5. So when x is 4, this is 5. And then we can also go ahead and find the x-intercept. So x-intercept is when y equals to 0. When y equals to 0, our x-intercept is 3 over 2. So we get 1.5. Let me just clean this graph up. And this will be our final answer. So that is it for chapter 1.1. Let's recap on what we learned today. So we looked at what's a function. Function is the relationship between an object and an image. We learned how to write function notation in 2 different ways. We learned what's not a function. So a function is only when an object has one image. We learned how to write domain, codomain, and range. And we learned how to sketch a function. I'll catch you guys in the next video for chapter 1.2 and 1.3. Take care.